I'd like to spend a little bit of time working through the homework assignment that you guys had from last week, and that would be 13.1 and 13.2. And if you get any of these wrong, I expect you in a different colored pen to correct yourself. And when we're done with both of these, I will have assignments on Neo that you can submit, and it'll say 13.1 corrections. Instead of submissions, it'll be corrections in all caps. Okay, starting with number 2. Write down the coordinates of points P and Q. So on my end here, I'm just going to write basically the answers down. So 2A, the coordinates of point P and Q. So when you're writing down the coordinates of a point, you usually use a capital letter, and then in brackets you put the x coordinate and then the y coordinate. So for P, it's at 4 over, right? So 4 comma 1, 2, negative 3. 4 comma negative 3. And then for part B, oh, they want Q as well. I thought Q was part B. It's not. So the coordinates of Q are 4 comma 1. All right, part B. M is the midpoint of P and Q. Write down the coordinates of M. Okay, so the midpoint of PQ is halfway between P and Q, and so it would be wherever the dead center is. So it'd be this. If you were to put your pencil there like I am, there should be an equal amount of spacing above and below that point. And where I have my pencil is the correct spot, and so that would be the coordinates 4 comma negative 1. That's all. All right, next up, number 4. On a coordinate grid, plot the points 6 comma negative 1 and 2 comma negative 5. Join them with a line. So I'm going to shed the book a little bit here so that I can have more room to work. And I do expect you to be doing this in your exercise book as well. I should at least see a coordinate grid. If you were an IGCSE student of mine, I would expect the instructions and everything. So there's my rough coordinate grid, and they want you to plot the points negative 2, let's see, it's number 4. 6, negative 1, okay, 1, 2, 3, 4, 5, 6, negative 1, and then 2 comma negative 5. And then join them with a line. Okay, so there's my line. That's part A. Okay, part B. Work out the coordinates of the midpoint of the line. Oh, that's kind of tricky because it's slanted. You know, the other one was vertical, this one's slanted. But the same kind of principle can apply. There will be much better methods to find the midpoint, but you just simply haven't been exposed to them yet. Maybe now would be a good time to talk about that. Maybe now would be a good time to talk about that. 1, 2, 3, 4, 5, so 6 comma negative 1, and then 2 comma negative 5. Okay, so if you use the pencil method, you just kind of try to put your pencil halfway, and you would be pretty much accurate. It's really convenient because the midpoint itself is kind of on an intersection. It's on an exact coordinate, so you won't have a decimal. All right, and so in this particular case, the midpoint, and it's sometimes signified with a capital M, the midpoint is at 1, 2, 3, 4, 1, 2, 3, so 4 comma negative 3. All right, so boom. If it was like a decimal, then you wouldn't be able to use the pencil method. So really quick, one way to find the midpoint is just to find the average of 6 and 4. What's the average of 6 and 4? How do you find the average? You add them together, and then what? Divide by 2, right? And so the x coordinate of the midpoint is just going to be 6 plus 4, which is 6 plus 2, sorry. 6 plus 2, which is 2, which is 8. 6 plus 2, which is 8, divided by 2, which is 4. Okay? And then you do the same thing for the y coordinates. Negative 1 plus negative 5, and then divide that by 2. You're really just finding the average of the 2 points. Negative 1 plus a negative 5 is a negative 6. Negative 6 divided by 2 is negative 3. So when you simplify this, you'll get the same result as the what we got with our pencil method. So 6 plus 2 is 8 divided by 2. Negative 1 minus 5 is negative 6 divided by 2. And that becomes also the same as before, 4 comma negative 3. All right, so that's just something that you're going to have to do in the future. You'll have to use this. It's called the midpoint formula. But for now, they probably will give you easy, I'm assuming they will give you easy questions that are nice and non-decimally. Number 8. Draw the quadrilateral with corners 5, 2. Here we go. Let me show you. Draw the quadrilateral with corners at 5, comma 2, 3, comma negative 2, negative 3, comma negative 2, and negative 1, comma 2. So let's do that first. They also want you to give the name of this quadrilateral and find the coordinates of the center of the quadrilateral. That's kind of tricky. Okay, so let's see. Coordinate grid again. Five, 2. Three, negative 2. Negative 3, negative 2. Negative 1, 2. Okay. And it's a quadrilateral. Right now we just have 4 dots. Quadrilateral means 4 sides, right? So we need to make 4 sides. We're connecting the dots. Okay, that's part A. And part B, what is the name of this quadrilateral? Is it a parallelogram? Is it a rhombus? Is it a rectangle? Trapezoid? What can it be? Well, let's see. It's a parallelogram if if the opposite sides are the same, right? Or are parallel, I mean, and equal actually. So is this parallel to that? Yeah, I think it's very clear that the top is parallel to the bottom. They're both horizontal lines, right? What about these? Is this side parallel to this guy? That is kind of tricky, and you're in the next lesson, or 13.3, there's going to be some talk about a gradient. So you can tell if opposite sides are parallel, if they have the same angle. We're going to call it gradient soon, but it's basically, are they going up and right the same amount? So from this dot to that dot, 1, 2, 3, 4 up, 2 over, right? It's 4 up and 2 over. And then is it the same up and over for this guy? 1, 2, 3, 4 up, 1, 2 over. Yeah, it is. So you can actually put parallel marks on these opposite sides as well. So since the opposite sides are parallel, you can call this a parallelogram. It can't be a rectangle because it's not 90 degrees here, not a square, so you don't have to worry about that. The best we can do is call this thing a parallelogram. Part C, find the coordinates of the center of this quadrilateral. Okay, all right. The center of this thing. Well, that's like when you find the midpoints, it's like where all the midpoints connect. What's the midpoint here? Looks like right here, isn't it? If you use the pencil method, it's nice and even, right? Yeah. And then 1, 2, 3 here. If I put a dot here, there's 3 on either side, so perfect. So if I connect these, it's getting a little bit of like a cluster diagram. But if I draw a line connecting these midpoints, and then I do the same thing for the other midpoints, wherever they cross is going to be the coordinates of the midpoint, or the center of the diagram. So let's see. Looks like this, where my pencil is the midpoint. It's over right up 2, and then down left over 1. So the same method that I'm using to find the gradient, I can kind of do the same thing to measure the midpoint. And it's kind of like I'm making a right triangle, and this has a length of 1, and that's a height of 2. And I'm doing the same thing here. This is a height of 2 and a length of 1, so these hypotenuses have to be equal because these triangles have the same side lengths. I think it's more clear if you just in this particular section just eyeball it. So here we go. Here's a midpoint, and if you kind of look on the other side, there's the midpoint. So in this particular case, when I connect the midpoints, I'm just drawing a part of the x-axis. So then the point of intersection would be right here. And so the question is it right on the coordinate on the midpoint there, the intersection right there, or is it off? Is it like a decimal answer? I would say in this particular lesson, you don't have the knowledge yet to figure out if it is a decimal. So let's give the coordinates of this point here, which it very likely could be anyway. And so the coordinates of the center of this quadrilateral would be at 1, 0.